Well, hello. I'm here to talk about how large language models work with Caitlin. But first, she's got a European Space Telescope.
Yeah, another space telescope. So we had Hubble for a long time, and then Webb went up, and now Euclid has gone up. So Euclid costs about $1.5 billion. And the article we're looking at is on Ars Technica by, once again, our friend Eric Berger. So I'll pull up the article right now. So Eric wrote this article talking about the Euclid Space Telescope. Now, Euclid is from the European Space Agency, not NASA. And what's interesting is that it's only 1.5 meters in aperture, and it focuses a lot on visible light. And it just took its first photographs, and it's working well, and it's nice to see more telescopes in space. And yeah, I just wanted to show everyone its first light. Looking good.
And what's the advantage? I mean, isn't it duplicating what Hubble did?
Hubble was not looking at visible light. It was looking at very specific wavelengths.
Oh,
And this is more for so Hubble also is very zoomed in. This will take much larger frames or a larger field of views of the sky. So that, like I said, it's not as big of a telescope as Hubble, but it will be taking visible light images, which will be very interesting because we've never had a space telescope that did visible light images.
yeah. I just wonder how it compares to like adaptive optics from the ground that have gotten so good.
I don't know. I've been using adaptive optics with my telescope, and it's really amazing. I don't even, well, the way it works on consumer hardware. I know in observatories they like shine a laser and they track like where the laser is being diffracted by the atmosphere. What I do without a laser, because lasers are a bit dangerous to point unless you know exactly what you're doing.
Yeah.
Um, what you can do is you can take a video of your object, and because it's really the effects of the atmosphere are only for things where you're really zoomed in, like the moon or the planets. And what you do instead of shooting the laser, you take a video and you'll take it for like 30 seconds, maybe 2 minutes. I've done it for like 2 minutes, and you run it through special stacking software that goes through the image and sort of tracks where all the points are, and then sort of deduces what has been altered by the atmosphere, and you get images out. And it's really good. In fact, I can show some pictures since we're on the topic of how this works. But
Yeah.
yeah, actually, let me do that. I'll throw. I have some pictures here. I can share.
Yeah.
I'll have to. I'm going to be sharing my desktop, so I want to minimize some stuff before I do that.
So it just follows one star and moves it around so that it can compensate for the effect of the atmosphere, which is like a wedge moving things around in random directions, right?
Exactly. So
The only
here
thing
we
that would hurt
go.
is if the air was so turbulent that the rate of slope of the gradient changed across your image.
I mean, it's never been that bad for me. So
Yeah.
let me see if I can't.
Seems like it would be fine as long as you didn't have high velocity turbulent wind.
All right, so here we have an image of the moon.
Mm-hmm.
And I think this is probably the best image I could do with my small refractor. So my refractor is only 73 millimeters in aperture. It's very small,
Mm-hmm.
really not meant for these close-ups. But like I said, what I did instead of taking an image of the moon, I took a series of videos,
Mm-hmm.
and then the software tracks where it's supposed to be and then creates the image. So you'll see like there's no atmospheric distortion at like the bottom of the moon. No matter how much we zoom in, it just looks like it was almost taken in space.
And if you
Uh,
apply AI enhancement, you could do even better, of course.
yeah, that's a big problem. You don't want the AI hallucinating your images.
Well, that's
But
yeah.
yeah, no, but you can use. I use that for the moon and what else? So keep in mind, this is a very small telescope, but I was able to get an image of Jupiter out of a small telescope.
Yeah.
And I think I did Saturn as well. Yeah, there we go. There's Saturn from a very small, tiny portable telescope. I've seen Saturn before through big telescopes, and it just looks like rabbit ears. You can barely tell there's a ring, but with a small telescope that's not designed for doing any planetary work, adjusting for um, the atmosphere, you can clearly make out that these are indeed rings and stuff like that. It's really amazing what you can do with adaptive optics.
Yeah, very
Oh,
nice.
and since I'm showing off, Sam, you'll like this.
Oh,
So that little
you know,
that is Pluto, taken from a 73 millimeter aperture telescope.
that is really impressive.
Yes, yes. But it just looked like a little dot because
Well,
obviously,
seeing details on Pluto would be incredible, but seeing it
yeah,
at all is good.
yeah. But yeah, adaptive optics, modern stuff on the ground, you can do amazing things even with smaller telescopes. And in fact, I think this month I'll be getting a larger telescope, one that's a bit more. We'll get nice images of the planets and stuff.
And this is all with city light pollution too.
To be fair, I designed my telescope to be a light pollution buster. But yes, it was not only with. So in light pollution, we talk about like Bortle. Like Bortle 1 would be perfect skies. Bortle 9 is the worst. Turns out Sunnyvale is Bortle 9. And I do it in a parking lot with floodlights.
You know,
So
some night we should just drive someplace dark.
we could see that's the traditional solution is
Yeah.
you drive somewhere dark, and you do your astronomy there. My solution is I am going to engineer the hell out of a telescope to make it work even with the worst type of light pollution.
That's true. That's another option.
And it's working, and it's actually working. I am getting these images out. They're fine.
Yeah.
In fact, even behind me, this is the what's it called? The Omega Nebula. Let me move my head.
Yeah, you should. Yeah, there it is.
Yeah,
Let me
there
make
we
it
go.
bold there. Very pretty. Yeah.
Yeah. So I mean, and that was and that was also taken in addition to borderline skies, and in a parking lot with floodlights. The moon was right below that, the full moon.
Mm-hmm.
So when I say this is a light pollution buster, like I said, I mean, just modern telescopes, just in the past few years, have just exceeded all expectations. I could not do this a decade ago. This was not possible without EAA or electronically assisted astronomy.
Well, very good. All right. Well, anyway, I saw this article about Toyota's new battery. Toyota is making a solid state battery, which is not like the lithium ion batteries. And these things can have a range of 745 miles and charge in 10 minutes. And they do not have a fire hazard when they break in a collision or something. So they sound wonderful and they should revolutionize the system. Of course, the problem is they're not 100% ready to be manufactured yet. There are still some problems scaling up the manufacturing and issues with the costs and the lifetime. So we'll see how this goes. The Toyota is pushing it. They're also pushing hydrogen cars at the same time. They're just trying many different ways of making less environmentally harmful cars. But anyway, it sounds great, offering a safety advantage and making EVs, getting rid of the range anxiety, where they will go just as far as gasoline cars and charge up quickly so you don't have to worry about the range. So it sounds great. We'll see how well that proves out in practice. And back to you, you've got the hallucinations that won't go away.
Yeah. So when people started using ChatGPT, the first thing everyone noticed, of course, was the hallucinations. This thing just spits out bad data left and right. And we talked about this before on the podcast. A lot of this has to do with just its training data. It doesn't understand the words it's saying. It just predicts what's going to come next. And unfortunately, a lot of people wanting to use this technology are putting it in use for like information. So like what I mean is like Microsoft added it to Bing, added ChatGPT to Bing. And I always thought that was a terrible idea because modern AI models or machine learning models are really great at generating content. Like you want your AI or machine learning to write a poem for you about cats in space. It'll do that. It'll do it great. It's fantastic. This is a game changer. But instead of using it to create content, a lot of people are trying, or a lot of companies are trying to use it to generate information or get information for you. And that's the wrong application of this technology. But of course, the companies are hoping to fix this problem, but it turns out it might not be. This might be just a fundamental flaw of machine learning as we know it right now. So Fortune has this article by Matt O'Brien in the Associated Press, and they're talking about how ChatGPT will always have hallucinations. Like, it's always going to be an issue as long as we're using the current model of machine learning. And once again, this really goes back to the idea that all the AI is doing is it's repeating words that it saw, and it does not understand the context. And until we start giving machine learning, nervous systems, and they can explore the worlds and understand what words actually mean, which the current models absolutely do not do that at all. It's just predictive text. It just thinks, what's likely to come next after a word, and it's just going to continue. It's just a unsolvable problem, it looks like. So,
well, we'll see. People are trying to solve it. Anyway, this gets me to the one I was very interested in. Ars Technica has an article by Timothy Lee and Sean Trott explaining how AI large language models work. And I found a lot here I didn't know. And I read that the revolution is the encoding of language. And they explain it here in wonderful detail, which I was unaware of. They have these chunks of text that are not exactly words, but other tags, parts of sentences. And they've made each line of text and each word essentially specified as a 300 dimensional vector. And they've made it so words with similar meaning are near each other in that complex space. And if a word has multiple meanings, it has multiple vectors that it maps to. And if a word can be both a noun and a verb, it represents both of those options. And so this means you're trying to all the text you feed in turns into a vector, and it just moves a hop and finds other words that are near that. So if it makes an approximation, it still gets a word that has a similar meaning to the other one. So it's really quite effective. And this, they say, is an essential technique. Now you have a way to map sentences and phrases onto vectors that encode their meaning and compare them to others. And they can even do something like add and subtract them. So there's an example here. Let me get this one up so I can see it. Okay, you can take man is to woman as king is to queen, and you can take big and find the difference between big and biggest and add that to small and get smallest, and that sort of thing. And this might seem simple, but it is amazing to me that the mathematics can do that. So it is very close to understanding what these words mean in that regard and being able to understand the relationships between words. So that's the essential part. Then it just learns mathematical ways to map these with layers of neurons, and they're trying to figure out what the neurons do. And just like in studies of the human brain, they sort of guess that the first layer is correlating words and the next layer is focusing attention on the important word and so on. But that's only a vague approximation of what it's doing. And nobody really knows exactly what the hidden layers are doing. But anyway, it's a very wonderful explanation, and it helped me understand better how these things work, which doesn't immediately answer a question like, can you get rid of the hallucinations? But certainly helps understand what they're good for and what they aren't. So anyway. And then you've got Elon Musk, the man we love to hate, like J.R. Ewing.
I was the first on the Elon Musk hate bandwagon long before it was popular, and I'm just so glad to be proven right. Everyone is now agreeing with me. So the Associated Press has an article by David Klepper talking about there was this old company called Twitter, but now it's called X. And a bunch of researchers were looking at X after the takeover. So this is just terrible. Elon Musk is a bigot. Let's just get that out there, right? He grew up in South Africa, one would assume, and just has bigoted ideas, a lot of white male privilege. And he also has this weird billionaire mindset where he just kind of went crazy with his money and started going QAnon-ish light a little bit, and going into the deep conservative rabbit hole and wanting to turn a social media empire that he bought for no good reason. Just he did because he's crazy. And he turned it into a hateful cesspool. Let's just put it that way. He if you go on to X, it's full of bigotry and not I mean they don't go as far as like full on KKK or Nazis, and I just think I got us demonetized. Um but it goes pretty far. There's lots of subtle jabs at minorities, lots of microaggressions, lots of regular aggressions, lots of people making fun of you know of people from other countries, making fun of women, making fun of gay people, that kind of stuff. And so some researchers, I really buried the lead here. Some researchers got data from X/Twitter and did studies to show that, yeah, no, it's definitely much more toxic now than it was before. And a bunch of advertisers then saw that and left, right? So what did Twitter do? Did they try to fix their app? Fix their app? Did they try to reason with Elon? Maybe say maybe we shouldn't turn this into a right-wing, echo chamber of hate. No, Twitter decided to sue those people who did the research. I mean, it's just yep. This is going bad. Much worse than even I expected. I mean, I knew Elon taking over Twitter was going to be a disaster, but this has just exceeded every bit of that. So
I thought that simple desire to make money would limit his craziness, but there's no sign of that happening yet.
I think he's so rich, the desire to make money is no longer a problem. And I've noticed that with myself too. Once I made enough money that I am, comfortable, right? Life stopped being about, making money and having enough money.
Yeah, but most of these billionaires don't seem to ever have a lack of the hunger for more, but maybe
yeah, I don't know. It's
yeah, but he has this delusion of grandeur that he's saving the human race. He thinks Twitter's going to be the solution to everything, and he thinks we're going to go to Mars, and he's going to save the future humans at the expense of the current humans and all that jazz. So he's got complicated justifications whereby everything he does is okay. As if who doesn't? Anyway, there's yet another flaw in CPUs. Like Spectre and Meltdown, and there's another one that came out recently, there's yet another, and this applies to almost all modern CPUs. And what you do is you do a similar calculation to the one that is supposed to process secret data, and then you measure the power consumption. And there is a problem with colliding in a cache. So if the data you're pumping in matches the data that's being processed in secret by something like a cryptographic key, it will consume a different amount of power. So again, if you can run malware on the device with low privileges, you can leak out high priority secrets like cryptographic keys. And again, this applies to almost all modern processors. It's called collide plus power. So like Spectre and Meltdown, it's another intrinsic flaw in the design of these processors and the whole current generation of them. And there people are trying to figure out how to fix it and how much performance you'll lose and so on. So that's yet another in this long series of fairly subtle flaws in processors that means they can't really be trusted to secure secrets. And it's a thing to be aware of. I assume patches will be coming, and we'll have to see how much this affects cloud services and so on. It's a fairly new report, so I think we don't know all the consequences yet. Anyway,
I was reading an article about what it means to truly be secure, and to have zero trust.
Yeah.
And you really can't have that unless you build your computer transistor by transistor, but then you have to trust that the people making the transistors don't know what you're doing, and that kind of stuff. So
yeah, everything is threat modeling. You have to decide how much risk you can tolerate and what risks you're worried about, and then try to control those risks.
Right. And it might be I mean, I'm thinking that a power usage bug would be very difficult to, do anything. I'm sure you could get data out in a controlled environment, but in an uncontrolled environment, it would be very hard, especially if you're dealing with a modern system that has like 16 APUs or CPU cores running at the same time. And then the power usage isn't really exact from a software level. Like I said, in a controlled environment, I'm sure you could do it. I could hook up a good oscilloscope, put on a little shunt so I could measure like current flow, and very precisely measure the power usage of one line of the processor, and be able to figure out exactly. I mean, but if you get to that point, you can just hook up a little like traces, little wires to the memory bus, and just read out what's being sent over the memory bus. I mean,
Yeah, well, one thing you might do, they're actually using an internal signal that tells it how much power is being consumed, and you could obscure that signal, I imagine.
you
And
could, and like I
that,
said, that power signal is not going to be super precise.
yeah,
So if you
apparently there's some kind of average power, but they showed that it's good enough. So if you just made it over a longer time range or something, I imagine that would help mediate this attack.
But that's what I'm saying. You would need a really controlled environment for this to work. And I, we have to wonder like how secure do we want our stuff to be versus, how much slower. And I always get a little nervous whenever there's a Spectre meltdown, because, then we have to slow down all our processors in response. And it's like, you'll never get your processor to be 100% secure. There's
Yeah.
always some attack you can do. The question is it secure enough? And if you do need it that freaking secure, I think that, what you should be doing is making a special processor where, it's designed in the country and built in the country it's supposed to be run in, so you don't have supply chain issues. It has no, prefetch. It does everything using the same number of clock cycles every time. So if you figure out what process takes the most clock cycles, division is one that usually takes a lot, and then you design your entire processor so everything takes the same amount of clock cycles, so you can't like deduce what's running from that.
Yeah.
You encrypt the memory. I mean, it would have to be a specially designed computer for security.
Well, I see an opportunity here. You could just continue to offer the cloud services the way they are, and then you
Yeah,
could have a more expensive service that has all this fancy stuff for the
yeah,
people who want more security, and that would be a good way to handle it.
that would be, yeah, like GovCloud on Amazon.
Yeah.
They definitely do that. I mean, it would be a slower system for sure, much
Yeah,
slower, but you would have that extra, level of super security that most people just do not need and do not want.
that's right. But this is America. You can just sell it at a higher price and make more money, and everybody will be
Exactly.
happy.
Exactly.
Yeah. The marketplace might be able to solve this. All right. Well, that's enough for this one, and we'll have another one on Friday.